Greetings everyone. Today we're going to talk about pyramids and cones, and we're going to talk about the surface area of pyramids and cones. Here we have several different pyramids. Notice that the shapes are different. They are categorized by the shape of their base. The base is a triangle, and it is a triangular pyramid. Here we have a base that's a pentagon. We have a pentagonal pyramid. Here we have a base that's a rectangle. That's a rectangular pyramid. Okay? Vary in height. Now, one thing that's interesting is this looks like a regular pentagon. With all five sides have the same length on the base. What would be special about a regular pyramid versus one that is not regular, such as this rectangle? I want you to think about that for a minute. What is different about it? If these are all the same length, then every face is congruent. Here, if these are different lengths on the base, then these two faces here are not congruent. Okay? And that makes it a little bit more challenging. So always look at your pictures very carefully. Let's try a problem. Or let's examine the pyramid first. Okay, here's a square pyramid. The top is called the apex. The bottom is called the base. We have four edges going down. But this right here is pointing to a vertical slant height. And that must be drawn perpendicular on that face. It's on the face. Okay? That slant height is going to be an important dimension. We usually use a lowercase l, possibly a lowercase s, is sometimes used for the slant height of a lateral face. This height over here, which is labeled h, don't label this one h. H is the actual height of the pyramid from the apex perpendicular to the base. And that also has to be perpendicular to the base. So h is the vertical height right here. L is the slant height. Now let's talk about the surface area of a pyramid. Well, how are we going to calculate that? Well, if you look at that picture, and I want you to do these visually, I'm going to do this different from the book. Okay? So I'd stay away from the book on this. The surface area of a pyramid is equal to the area of the base plus the area of the four sides. There's a total of 5 faces. Okay? Faces, I should call them. We have the area of the base plus the area of all the lateral faces. The base is a face, but it's not a lateral face. The lateral faces are the sides. Lateral means side. So the lateral faces. Surface area equals the area of the base times the number of sides times the area of one side. That only works if it is a regular pyramid. Okay? Because then all 4 triangles will be the same area. Let's try one. All right, here's a triangle. Triangular pyramid, I should say. And we're told that it is regular. It is 8 meters on a side of the base. I've pulled off here the data that we need for the lateral face. A very important thing to do, okay? The base is 8 meters long. The vertical height is 6 meters. We get that off the drawing. Important to pull out your data. In this particular problem, we're already told the area of the base. You're not giving enough information to calculate it, so they gave it to you. I want you to write your formula or your word sentence for these. The surface area is going to equal the area of the base, which is always capital B, plus 3 times the area of one lateral face, which I've called the area of a triangle, A sub t. one lateral face because all three lateral faces are congruent because the base is regular. We plug in those numbers and let's take a look at these units. Here we have what we're given as the area of the base. We have 3 times the area of the lateral face, which is 8 meters times 6 meters over 2, 1/2 the base times the height. Notice that meters and meters will give us meters squared, and we will end up with meters squared plus meters squared. We can only add like things, and there's our answer. This is your first homework problem. I want you to freeze your screen, copy that down. You have a square pyramid, 8 by 8 on the base with a slant height of 12. I want you to calculate the entire surface area around to the nearest tenth. And there is your solution. The base is a square, so all the lateral faces are identical. Okay, you need this formula. Okay, you need a word sentence or a formula that's going to describe how you are going to do it. Not everybody has to do these the same way. The surface area is going to equal the area of the base plus 4 times the area of the lateral side. Notice I pulled out my data here on my triangles. Okay, that's very important to do because you'll have drawings with more dimensions and you may pull off the wrong one. So list them. And there's your solution. You can study that and freeze your screen. Now I want to move on to cones. Let's talk about some definitions. The base, we talked about the base. It's the same as the base on the pyramid. Really, a cone is a circular pyramid. Okay? We have the base, we have the vertex, we have the vertical height down the middle, and we have a slant height. Remember, the capital B stands for the area of the base. Now, if we do you ever get one of those ice cream cones that has the paper on the cone that you have to peel off so you can get all that ice cream out and eat the cone? And you peel that off and you end up with a shape like this, right? That's our cone. Depending on how tall the cone is and how wide it is, it's going to be more or less than half a circle. Okay? Now, we know what the area of the base is. This is pi r squared. Okay? This turns out to be pi rl. You do not need to memorize that. I will give that to you on a test or quiz. Okay? But the area and circumference of a circle, you obviously need to know. And so that is our cone. Okay, let's try a problem. So the area of the base times the lateral area. Let's try one. Finding the surface area of a cone with a radius of 4 meters and a slant height of 9. Formula. S is going to equal the area of the base plus the lateral area, which I've designated by A. Pi r squared is the area of the base. Pi rl is the lateral area. We're going to plug our numbers in. We're going to make sure that we end up with like units. R squared is going to come out to meters squared. You must put this in parentheses or it is wrong. 4 meters times 9 meters is going to be 36 meters squared. Okay, the meters times the meters. And you end up with 163.4 square meters approximately. Now, let me make this point here because I've seen this on some work. You cannot say that the area of the base is equal to pi times 4 meters squared. This 4 meters squared is just a measurement of 4 meters squared. If you don't do that, it's wrong. Okay? That squares the 4 meters, so you end up with 16 meters squared. I have one more problem for you. For those of you who want a challenge, you can freeze your screen and do this. Actually, this is the last screen and I'm not going to solve it. So I would like those of you who would like a challenge to try this problem. Notice that this is not a regular pyramid. The sides of the base are 3 and 6, and the only height given is the vertical height through the middle. I want to see what you can do with that, and let me know, and then we'll go over it when we meet. And that's it on pyramids and cones.